Good morning once again, class. Today we're going to discuss an offshoot of multiple linear regression, and it's called binary logistic multiple linear regression. What we're going to discuss now is binary logistic regression. So please don't mind the date. We used this last April. Okay, so uh, sometimes it's very important to know where your default directory is. And to get that, to get the default directory, you use get working directory. So if I run this, so my directory now is in drive C users admin downloads. Of course, you'll have a different directory. Now you can set the working directory, okay, and it's very important that you set that so that when you save files or when you work on certain files, it's best to put your files there in the working directory. Okay, so you can change the default working directory by changing the location of your directory. Okay, so I asked you to download the data. Okay, and we name the data dot. Okay, so let's view this first. Okay, so our data has 14 variables and 1,388. Wait. No, sorry. Okay, my mistake, no? I have to run this control enter. Okay, there. So this is our data: admit, GRE, GPA, and rank. So there are 4 variables here and 408 entries. Now the admit here is if you take a look at this, this is a binary variable 0 or 1. And this is the result of an applicant. Okay, admit 0 means the student was not accepted, and 1 means the student was accepted. So the objective here is to predict if a particular applicant with grade GRE level, GPA, GPA from his former school, and the rank of the school will be accepted or not into the program in this college, this university. Rank 1 means higher, good rank. So this is 1, 2, 3, 4, 4 rank 4 being the lowest. So they were ranking the school. Okay, this university ranked the school where the student came from, and our response variable here, our dependent variable, is admit. So if you notice, the admit variable is not continuous. Ano siya, yung kung tutuusin, it's not even an integer, no? 0 or 1, this is used as a classifier, no? 0 meaning hindi natanggap, 1 natanggap. So this is an example of a factor, no, which is used to classify, and we cannot use ordinary least squares for this one. That's why we need to use what we call binary logistic regression, which is your second quiz. So pay particular attention to the variable of interest, no? Kung ano yung predict natin, dapat binary siya. Okay, so let's continue with our na-double yung view. Tanggalin ko na nga ito. Let me delete this. Okay, so let's take a look at the structure of the data. Oops. Okay, so if you can see, admit here is an integer. GRE is an integer, that's okay. GPA is numeric, and rank is an integer. Okay, so what do you think should be changed here? Should admit be treated as an integer, class?
No, sir.
How should we treat it, class?
Binary.
Yeah, thank you. Binary na, Jaime?
Ano? Hindi ko for sure, sir.
Pag binary kasi, maraming ibig sabihin. Binary, dalawa. No? But it should be treated as a factor. No? Kasi 0 or 1, binary din naman yan. Eh. Pero we cannot treat this as an integer because an integer, 0, 1, or 1, is also 0, 1 is binary. However, we would like to treat this as factors. Remember, class, yung factor, ibig sabihin ng factor? Yes, thank you. Thank you, Sophia. Yes, it should be factor, no? Kasi hindi siya, it's treated as a classifier. We've met this several times. Diba yung race, yung gender, mga factors yan. Even rank, class, no? Integer siya dito. So, we're going to reclassify them as factors. Okay? So that's what we're going to do first. All right. Now, here the function crosstabs, okay? The function crosstabs will give us a two-way table of the factor variables. Okay, so the function here is yung tilde, admit at saka rank. So it will create a two-way table for admit and rank using the data dot. So if you run this, okay, so here you have admit on the rows and rank on the columns. If you change the order of this, then kasi ito muna yung rows and then ito yung columns. So if you want a change in the order, then put rank first and then admit. So what does this tell us? Okay, so these were the ones who were not admitted. Okay, 28, 97, 93, and 55. Okay, for rank 1 schools, 28 were not admitted. And then, how many were admitted? For rank 1, 33. For rank 2, 54. Okay, for rank 3, 28. And for rank 4, 12. Okay, so this is a two-way table. So we can see the distribution of those who were admitted and not admitted based on the rank or the level of the school. Okay. Okay, ito, no? So we haven't run this. So from the dot data, admit, we will convert it as a factor. Okay. And then yung rank also, the rank variable, we will convert it as a factor. All right, so let's run this. Control Enter. And let me rerun the structure, Control Enter. All right, so now our admit variable is a factor and our rank variable is also a factor. Okay, pause for a while. Any questions? Is this clear so far? Okay, good. Notice, class, that I believe that at this point in time, you have gained a certain level of competency as far as R is concerned. So I hope you're, quote unquote, enjoying, and I hope you're learning a lot in this subject, in this course. Okay. All right. Now, this is the first time we're going to do this. Okay. So we did not do this in our OLS. This is actually part of the machine learning toolkit. Okay. Ano tong gagawin natin dito? We could have done this. Sorry guys kung medyo sometimes na kasi I have a stomach pain no pag umaano yung position ng katawan ko parang kaya don't mind kung bigla akong parang mapapagano. Okay, so yan, partition data. Now, if we use kasi, di ba, ang data set natin, okay, ang data set natin, class, is 400, no? If we're going to use everything here, okay, if we're going to use everything, and we might find ourselves suffering from what we call overfitting. Okay, dali. Overfitting. Yeah. Okay, that's a problem if we're going to use all our data set, no? All the 400. So in machine learning, what's being done is we partition the data set. So what do we mean by partition? We split the data into sometimes 2, sometimes 3, and call one part data as training data set, okay, and the other one as testing data set. So training, training and testing data set. Okay, so what's the purpose of this? What we're going to do is we're going to model the training data set. Okay, and then use the remaining part, the testing data set, and see if our model that we generate from the training data set works also with our testing data set. Okay, so we're going to test and see if the model that we generated in training data set can also work well with the testing data set. Okay, so that will prevent overfitting. Okay, so gagamitin natin, we're going to use the model that we generated in training and test it on a data set that it has not yet seen. Okay, kasi hindi pa nakita ng model natin yung testing data set. All right, so that's what we're going to do now. We're going to partition our data set into 2, training and testing. Now, anong percentage? Usually, depende sa size ng data set natin. Some would use 70-30, some 60-40. If the data size is big, then okay lang yung 60-40, 65-35. It's arbitrary. No? For our sample size, kasi maliit lang siya, 400, we'll just use 80-20. 80% training and 20% testing. Okay, so since we're going to partition our data randomly, it's important that we set that seed. If you recall this, guys, what's set that seed for? Do you recall yung set that seed natin, class? Or have we used this in class? Hello, class?
Not yet, sir.
Sure kayo? Hindi pa? Hindi ko pa na-discuss kung set that seed. Sophia, could you kindly share your answer to everyone? Does anybody remember us using this? Ay, sorry. FINTSAR pala yun. Okay. All right. Okay. So, yung set that seed, class, kasi kung i-randomize natin to, kasi ang question, paano i-split yan? Hindi pa pwedeng yung splitting yan, let me show you. Okay, kunyari ito 1 to 400, di ba? So, it's not good for the split, for the partitioning to be done. 400, sabi natin 80% is 320. So hindi siya maganda kung yung 320, yung first 320 will be the training data set and the last 80 will be the testing data set. That's a poor way to do it. Bakit? Kasi we don't know how this data was arranged. What if this data was arranged one muna lahat, no? Yung na-admit mo na lahat. I'm just giving an example. If this was arranged na yung lahat na admit, in other words, chronological, no, one muna, and then, or sorted siya from 1 and then 0. Then, yung ano natin, yung magiging sample natin, karamihan 1 dun sa training, no? So that's not a good way. Do you get my point, class? Paki-chat naman kung clear yung ano. Hindi pa pwedeng yung 1 up to 320, group 1 yon, and then 321 to 400, group 2. Kindly chat please if that's clear kung bakit hindi siya maganda. Kasi we're not sure about how this data was arranged. Class? Okay. All the rest? Okay, thank you. So there has to be a way for us to randomly arrange the data. Okay, and how do we do that? We can use the sample, okay, the sample function. So let's first see ano bang ginagawa nitong sample na to. Question mark. Sample. Oops. All caps pala. Okay, so this is from the base R pa rin to. Stats package yata itong sample. Saan siya? Ito sa base R. Okay, so base R. RS sample. Here. Sample. Let's take a look at what this does. So this is from base R. Okay. Sample takes a sample of the specified size from the elements of X using either with or without replacement. Okay, so kukuha tayo ng sample from it's like drawing parang yung basic example na na sa stat na drawing marbles from a container. Okay, so ito ang dino-draw out natin yung mga numbers. So ito yung syntax niya. Sample X yung size, replace yung with replacement or without replacement. Okay, and then there are I think some examples here. Okay, so let's do this. So ginagamit natin yung sample na function. Okay, first we're going to create an object called parang index to, no? Index, and then using the sample function. Okay, dalawa, no? 2 means we will be grouping it into 2. Okay. Tapos, let's take a look at the syntax. Yung size, hindi natin isusulat 400 dito. Kasi 400 yung ano natin, di ba? Yung number of, yung size ng data natin. We're going to use this, n row, dot. So this is a better way rather than write. Para kunyari pag nabago yung dot, mababago din to. Pag i-run natin yung size ng dot, kung magdadagdag tayo o magbabawas. Okay, and then replace is equal to true. So, or false. Ang ibig sabihin ng replace, kasi pag kumuha tayo ng number, and then, pwedeng ibalik natin. No? Okay. And then, probability is 0.8 at saka 0.2. Alright, so let's run this first. Run natin tong index na to. Control Enter. Okay. So now we should have this in here. Natin sa environment natin. Okay, na-run ko na ba? Control Enter. Okay. Where's my ind? Here, guys. Huh? Ind. So it's a vector. Okay. So i-view nga natin. Let me view. Okay. Oops. Hindi siya napiprint. Ano na lang. Dito na lang. Okay, let me print the first 50. Head ng end ng first 50. So if you take a look at this classification, yun yung 1, 1, 2, 2, 1, 1, 1, 1. So what does this tell us? This is how our data is classified. Oops, wait. Pareho ba tayo, class? 1, 1, 2, 2, 1, 1 sa inyo? Paki-chat nga, please. Are you getting 1, 1, 2, 2, 1, 1, 1, 1? No, okay. No, ibig sabihin, class, yun ang importance itong set.seed. Because I did not run this yet. So set.seed, so nakita natin, class, kung hindi tayo mag-set.seed, pagkakaiba yung ano natin, yung grouping niya ng into training and into training and testing. So we have to run this so that we have the same groupings, no, ng data natin. So I'll run that first, Control Enter. Okay. And then I'll run this again, itong dalawang to. Control Enter. Okay. All right. And then kindly check now. 1, 1, 1, 1, 2. Okay. We should have the same. No? We should have the same grouping now. So pareho yung training data set natin. So that we have the same answers and so that mako-compare natin. Okay. Paki-chat please kung okay yung ano, yung pareho yung ano natin, yung training data set. Okay, good. And the rest? So yung pang 27 na sa data natin is number 1. So papasok siya sa training data set. Okay, good. So now you see, guys, the use of yung set.seed, no? Para pareho tayong ano, pareho tayong training at saka testing data set. All right, so we will now create 2 data sets. The first one, we'll call it training data set, train, and the second one, testing. So as I said, what we're going to do is we're going to model yung train data set natin. Okay? Tapos kung ano mang model na makuha natin dito, we're going to use the testing data set on the model to see if yung model natin kayang magandang predictor pa rin kahit testing yung ginagamit natin. Okay, so let's run this too. Control Enter. So we now have two data sets, no? Training and testing. And you notice na hindi siya exactly the same na hindi siya eksaktong 320 kasi 80% of 400 is 320. So 325 for your training data set and 75 for your testing data set. If I click this, so notice, sino pumasok sa training data set? Si 1, 2, 3, 4, wala si 5, di ba? Si 5. Kasi si 5 napunta siya dun sa testing data set. Sino pa? Si 14, wala. So dito yun, no? 1, 2, 3, 4. Si 5 is group 2. Next group 2 is 14. All right? And then if I check yung training data set na and testing data set natin, okay, 75 observations lang siya And then it's from 5, 14, 16 of the original, the 80 data set natin. Okay? So kindly now chat if clear yung pag-generate ng testing dataset at training dataset. And we could have done this, guys, no, sa unang lesson natin sa OLS. It would have been good for us to, kaso at that time, I didn't want us to, I didn't want us to be bothered by so many things all at once. So, ang focus natin doon, OLS. Ngayon, ito, I think, so, kasi kaya na naman natin yung paggamit ng R at saka yung si Logistic. That's a special case lang ng regression yan. Okay, so clear so far, class, yung pag-generate ng training and testing data. So, paki-chat naman, please. If you have any questions, feel free to raise your hands or chat, please. So only 4 so far. Let's wait for the others. How about the others, class? Okay. 9 pa lang out of 24 participants. Any questions ba, class? I'm getting a very low response rate from you. Pause ko muna yung recording. Please remind me. All right, so let's proceed. So meron tayong dalawang dataset, di ba? Training at testing. Si training ang gagamitin natin para i-model natin. And then once we have the result, gagamitin natin si testing and see if our model would work well also, if it works well with a data that it has not yet seen. Kasi nga, sineparate natin itong testing dataset natin. Now, I just want us to, tingnan muna natin class, no? I-rerun natin to. What will happen if yung replace is equal to false? Kasi yung true, ibig sabihin, pagka-draw out na ng number, pwede niya ibalik yun dun sa container. No? So, let's see. Ito, i-run natin itong buong to. Okay. Magbabago ulit yung ano natin, but it's okay. Pwede na naman natin i-run ulit. Control Enter. Ano nangyari? So, can you guys, cannot take a sample larger than the population when replace is equal to false. Alright, so nagkaroon tayo ng syntax error kapag replace is equal to false. Cannot take a sample larger than the population when replace is equal to false. Alright, so may question ba? Okay, thank you. Right? So we have a syntax error kapag nagpo-false tayo dito. So i-true natin to. Okay. So andun pa rin yung ano natin, no? Anyway, hindi na run to kanina, no? All right. So let's now go here. Okay, let's see. I-regress natin, no? Let's call this my model. Use LM to regress admit on GRE, GPA, and rank. Data natin, take note, data natin is string, hindi na yung original na data na dot. Ito na yung 325 observations. And let's see what happens when you run this. Pakirun nga, class, and tell me what happened. Did it run? Okay, yeah. It did not run. No? Hindi siya nag-run. Okay, others, guys? What about the others? Isa lang yung nag-chat, class. Yung iba, okay, let me wait for your response. I want to make sure that you see what the result was. Okay. All right, thank you. Thank you. So it will not run, guys. Like, mag-error siya. Okay. Bakit? Kasi itong LM, okay, it will not work for a variable that's a factor or a binary. Okay, so we need another function for that. Okay, and dito papasok, question mark na natin, class, GLM. Okay, generalized linear model. Okay, so this is what we use for binary logistic regression. There. Sa help function ni R, makikita natin, fitting generalized linear models. Okay, so you now see the difference between using ordinary least squares and when we're modeling binary logistic regression. So GLM is used to fit generalized linear models specified by giving a symbolic description of the linear predictor and a description of the error distribution. So if we take a look at this, guys, GLM, yung formula natin, yung family is equal to Gaussian, and then here are other syntax, ano? Tapos, if we take a look at this, saan ba yung family natin? Okay, data. Okay, so family, no? A description of the error distribution and link function to be used in the model. For GLM, this can be a character string naming a family function. Okay, so tingnan natin yung family dito. Right. So family, ano yung mga pwede? So maraming klaseng pwedeng gamitin sa family. Ito yung kailangan natin, yung binomial natin, no? Binomial, may Gaussian, may gamma distribution, may inverse. So maraming, there are many types of distributions. For our purposes, we're going to use yung binomial. Okay, so let's go back to our model. So this would now be the correct way to model this. So I'm now calling it mod, and it's GLM, same response variable admit, same predictors, yung tatlo. Tapos data is equal to train. Okay, and then family is equal to binomial. Okay, so this is now the difference between your ordinary least squares and your binary logistic regression. Tapos summary natin. So let's run this. Okay. Right. So we now have this output. Let's take a look at this first. So this is the formula that we're using. Admit, regress on GRE, GPA, and rank. Binomial, we're using the GLM, generalized least linear model. Okay, and then we can see here the coefficients. The intercept is significant. GRE is not significant, no? At 0.18. GPA is significant. Si rank, kahit na even if rank 2 is not significant, we're still going to include this because rank, take note, class, ano ginawa ni R? Automatically dynamify niya to. No? Okay, since there are 3 levels of rank, automatically ginawa niyang rank 1 yung benchmark, then rank 2, rank 3, rank 4 are included. So 3, di ba, K minus 1, 4 levels minus 1, so 3 dummy variables, of which 2 are significant, si rank 2 hindi significant. Okay, and then if you recall, this is to be interpreted with respect to rank 1. Okay. All right, and there are some other outputs here that are quite different from the ordinary least squares. My Fisher scoring iteration side dito, which we're going to discuss as we go along. Okay, now I think I mentioned this to you before, that if you want all the levels to be included as a dummy variable, what do? Ba tatanggalin natin intercept? So for example, dito, we're creating this model M1, GLM, admit, regress on everything, right? On that, everything yan. And then -1 means you're removing the intercept. And then ang result dito yung rank 1 kasama dun sa output. So run natin to. Okay. There. So in lieu of the intercept, kasama si rank 1, rank 2, rank 3, rank 4. Okay, pause muna, guys. Any questions so far? Okay, good. Thank you. All right. Thank you so much, class, for your responses. Okay, that gives me confidence na I'm getting through you. That's good. All right. So babalikan natin, guys, yung model natin. We're going to remove GRE because GRE is not significant. No? So it's like a backward regression, stepwise. Okay, so same thing na lang mod. And then GLM, admit, regress on GPA plus rank. We're going to remove the GRE. Okay, data, train pa rin, family binomial. Okay, so let's run this. And we have this model. Okay, so GPA, rank 2, rank 3, rank 4. So this is our final model. Okay, so 1.3735, 0.5712, etc. Now we're going to interpret this because for a binomial logistic regression, iba yung pag-interpret. Okay, so this is where we're going to spend some time with. Paano natin i-interpret to? Okay. Okay, first, let's predict. Let's get the values for, kasi ito yung ano natin, di ba? Ito yung train data set natin. So, si number 1, not admitted. Si number 2, admitted. Number 3, admitted, etc. Now, we will see how our model fared in comparison to the actual data set. Tingnan natin kung gaano kaganda yung model natin in predicting kung matatanggap yung isang applicant based on GPA and rank. Kasi we remove GRE. Diba? Hindi siya significant predictor of admission. Okay, so we're going to use the predict function. Okay, which we also use sa OLS, diba? Okay, so just to predict. Okay, so this is from the base. Base ba to? Base. Let's see. Okay, so this is from the stats package. It is a generic function for predictions from the results of a various model fitting function. So sa atin, di ba, regression, in this case, logistic regression. So the predict is a generic function which will predict, no, using our model kung ano man yung finifit natin. All right. So here, we're going to create an object called P1. Gagamitin natin sa predict. Ano yung gagamitin na model? Yung mod natin. Ano yung model natin? Ito, this one. This one, the GLM, using GPA and rank as a predictor. Okay? And then, ano yung data set natin? Yung trained data set. Okay? And then we have here type is equal to yung response variable natin. Okay, so let's run this. Okay. And then here, head ng P1. P1 is the prediction. I-compare natin sa head ng train. Siguro gawin natin tong first 20. And here, first 20. Okay, so let's run this. Okay, sandali i-round natin to, class. Three decimal places. Okay, kasi yung train naman natin, okay, 0 or 1 lang naman yan. Okay, so let's run this again. Masyado malaki pa rin, no? Ten lang, 10. Okay, run again. I'll just run this too. Okay, hindi siya pinasa side by side na. Okay, gusto ko sanang ano okay. Tanggalin ko ulit yung round class, no? I want us to see side by side yung result. No? Head, control enter. Ayun talaga. Okay, anyway, so let's take a look at this. No? One, two, three, four, five, six. Okay, 10 observations. No? The first observation is 0.282. Okay, 0.282 ibig sabihin less than 0.52. So this is not accepted. Okay? So si trained data set, ano yung una niya? Not admitted. So tama. No? Okay, the numbers here are probabilities. So 0.28, 0.29, 0.68. If it's less than 0.5, then ibig sabihin nun, 0 yon. No? If it's more than 0.5, then 1. Okay, you can see here that for the first one, 0.28, not admitted. Yung actual natin, not admitted, tama. For the second one, 0.29, not admitted. Ang actual is admitted. Right? Tama, class? Ay, sandali. Oh, wait. Kaya pala ako dapat to mali, sorry train and then yung admit lang kaya pala Tataka ko ba? Okay, sorry about that. And then ito, i-round lang natin. Ibalik ko to class. I was wondering why I forgot that. Ang gusto lang natin i-print yung si head ng admit, yung admit lang. Okay, so let's run this. Control Enter para may side by side yan. Okay. All right. So here now we can compare, no? Yung first 0.282, so not admitted yan. 0. Tama. No? Second 0.299 not admitted. Mali, no? Ang actual niya admitted tong student number 2 na to. Pero dito not admitted siya. This one 0.683 admitted to, no? Admitted, tama. So number 4, 0.129, not admitted, pero dito, ang actual niya, admitted siya. Okay, so we can see here, yung first, ilan to? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.311, class, not admitted, okay. 0.521, admitted daw, pero not admitted, etc. So for the first 10 respondents, or the first 10 data, yung first 10 observations natin class, we can see already that there are misclassifications. So hindi niya na-predict ng tama. Okay? Clear so far, class, ito.
Yes, sir.
Okay. How about the rest, guys? Clear ba so far yung predictions natin? Okay. Okay, thank you. Okay, good. Okay. All right. Now, we will have to, okay. Yung natin, guys, yung equation na to, itong mga values na to, it's not your regular regression equation. Okay? Yung y natin dito, ito yung equation natin. No? Our y is, may square dito. Pakitanggal nga guys yung square dito. Okay, sorry about that. Unlike sa OLS, where y is equal to straightforward, y is equal to beta null plus beta 1 x1 plus beta 2 x2, etc. Kapag logistic class, yung y natin is this is called the log odds ratio. Okay, let's see. Oh my God. This one, tawag natin dyan, log odds ratio. Okay, that's called our log odds ratio. Okay, this is the log, yan. Okay, and this is the odds ratio. P is the probability of being accepted, and 1 minus P is the probability of not being accepted. Okay, kaya ang tawag dyan, odds. What are the odds of being accepted? P, probability na ma-accept ka. Of course, 1 minus P is the probability that you will not be accepted. Okay? So, take note that for a binary logistic regression, iba yung Y natin. Di ba sa ano natin, sa ordinary least squares, Y is equal to straightforward. No? Wala ito. Now, in this generalized linear model, naiiba guys yung ano natin, yung Y. So, Y is equal to the log odds ratio. Okay, pause muna ako kasi I'm sure this is the first time you're meeting this concept. So, take note, class, magkaiba yung ordinary least squares sa binary logistic regression. So, ordinary least squares, yung Y natin, whatever, kunyari, if admit is a continuous variable, kunyari hindi siya binary, no? It's a continuous variable. So Y admit is equal to yung model natin, straightforward. Pero sa logistic regression, okay, what's generated is the Y is equal to log odds ratio. Okay? So again, what's log odds? Ln log ng yung odds ratio natin is the probability of being accepted or probability na yes, whatever we're testing divided by 1 minus the probability of this is the probability of not being of a no, no? Yes and a no. Okay, so let me pause for a while and ask for your comments kung clear so far yung equation natin ng ng isang binomial logistic regression. Paki-chat please. Kung so far clear tayo. Okay. The rest, kamusta naman? Okay, I hope the others are able to follow. All right. So kakailangan natin guys ng konting ano dito, no? Ng konting mathematical manipulation. Okay. So if we substitute the values, okay, so this is our equation. Y is equal to log odds ratio natin is equal to beta null plus beta 1 times x1 plus beta 2 times x2 plus, okay, and since dadalawa lang naman yung ano natin, dadalawa lang naman yung predictors natin, magiging ano to, no? Y is equal to log odds ng beta null, this is the intercept, plus beta 1 times GPA plus beta 2 times rank 2. Diba? Hindi natin kasama yung rank 1 kasi it was used as a benchmark. Dynamify natin to. Well, R did that automatically. Plus B3 times rank 3 plus B4 times rank 4. Okay, so far, class? Okay, I hope you're following along. Okay, pause muna tayo, guys. You don't need to hurry this. Let me entertain questions if there are any. Okay, good. Okay, I'll wait for the others to give their feedback. Okay, good. Okay, thank you. Okay. All right. Thank you so much. Okay, so let's now, I'm going to insert here, no? What do we get from mod, from our, okay, di ba ito yung laman ng mod natin, no? Ito, no? May coefficients. Okay, so if we get that, okay, so prinin ko lang yung ano, no? Yung mga coefficients ng model natin. Negative 4.72, 1.37, negative 0.57, okay? Rank 2, 3, 4, remember, these were dummified variables. Okay, so how do we now write our model? So ito na yun, guys, no? Y, remember Y is the log odds ratio, ha? Okay, Y is equal to yung log odds natin is equal to the intercept plus 1.375, okay, times GPA minus 0.57 times rank 2 minus 1.1645 times rank 3 minus 1.5642 times rank 4. Okay, yan yung equation natin. Yun yung mga values ng mga parameters natin. Okay, so this is where our model is coming from. Okay. Now, if we take a look at individual number 1, ito, si train data set natin. Ito, individual number 1. Ang GPA niya 3.61, okay? Tapos rank 3 siya. GPA niya 3.61, tapos rank 3 siya. So how do we now put that in our model? Okay, ito na 'yon, no? So this is now for individual number 1. Rank 3 siya, okay? So y is equal to your intercept plus ang GPA niya is 3.61. Ito, di ba? So isa-substitute natin yan dito. 1.3735 times 3.61. And then, rank 3 siya, ibig sabihin, rank 2 times 0 yan. No? Hindi naman kasi sa rank 2. Pati si rank 4 times 0 yan. So ang times 1 lang yung rank number 3. Yan. Negative 1.1645 times 1. Okay, so pause muna ako. And once again, I'll appreciate your chat kung so far nasusundan tong model na to. Okay, good. Okay, good. Very good. Okay, thank you so much, guys, for the feedback. I really appreciate that. Kasi, syempre, ayaw natin na parang nagpaparot lang ako dito na hindi pala maganda yung pagka-explain ko, no? I appreciate your honesty. It really helps a lot, no? Okay, tapos siguro, bago sana matapos yung term, let's see if we can arrange na hindi mo lang tayo nagkita-kita, guys, nasa FINTSAR na kayo. So let's see if we can arrange makapag one session sa Lasal, ano, kung ando dun kayo, kung makakapunta lang kayo, ha. Kasi I don't know if some of you are para magkita-kita man lang tayo. This is what I miss, hindi ko na face to face yung mga students, especially for a subject like this, no? Buti sana kung early years yung okay lang yun eh. Pero itong mga medyo major na, sana magkita-kita man lang kayo, no? Tayo. Would that be a good idea, class? Usapan na lang natin kung lahat ba kayo, class? Wala kayong, or do you have days na may klase kayo sa Lasal? Pa-chat nga please kung there are days na may face-to-face kayo. Monday lang. Okay, yung iba, okay, Monday, Tuesday, okay. O, may mga face-to-face pala, karamihan Monday. So siguro mag-arrange tayo na ano, na we can meet na si James Wednesday lang. Okay, siguro i-arrange lang natin. Ano lang yung parang special session natin para magkita-kita man lang tayo. Okay, sige, let's let's move on, guys. Okay, now if we compute for this, let's copy this. No? Let's copy this, Control C. Dito natin i-run sa console na lang. And enter. Ayan, this is the result, no? 0.933165. Ito yon. 0.933165. Okay, and hindi naman siya yung value dito, di ba? Ang value kanina dito, yung ito 0.282 siya, di ba? Yung observation number 1 natin, ang predict niya is 0.282. So saan nanggaling yun? Kasi ito negative 0.933165 yan. Okay, do you get my question? Class, ulitin ko para kasi importante yung question kung naiintindihan yung question. Di ba, okay, when we substituted for observation number 1, we substituted the GPA, yung GPA niya 3.61, at saka rank 3 siya. So rank 2 and rank 4 cancels out. So ito na lang yung contribution dun sa Y, no? And then when we perform this, lumalabas sa negative 0.933165. However, dito sa prediction natin, di ba dito? Oh, predict. Pinapredict natin yung model, ba? So, tas pinaprint natin yung first 10 observations. So, first observation, 0.282 lang. 0.282. So, saan nanggaling itong negative 0.933165? Hindi, alam natin kung saan nanggaling to, di ba? Ito, saan nanggaling to? Yun ang question natin. Saan nanggaling itong 0.282? Kasi ito, na-solve natin yung 0.933165. Saan nanggaling itong 0.282? Okay, so that's my question. Okay, paki-chat nga kung naiintindihan yung question. Okay, if you're following the train of thought. Please chat yes if you understand my question. Ang question ko, na-solve natin itong negative 0.933, di ba? Kinompute natin using the model and substitute the values for observation number 1. Pero, nung pinapapredict natin, bakit naging 0.282? Okay, so let me... Yes, Jaime?
Ay, for reset po ba, sir, or hindi po?
Sorry?
Are you asking po the question as recitation or?
Ano lang, kung naiintindihan yung question.
Okay.
But do you know the answer?
I think po, sir, kasi yung sinolve po natin na negative 0.9, siya? Yun yung log odds ratio, hindi, tapos yung 0.282, yun yung value mismo ng
Okay.
ng prediction.
All right. Okay, that's good. Thank you, Jaime. That's correct. No? So, plus itong value na ito yung Y. This is your Y. And remember, Y is your ln P divided by 1 minus P. Okay. So, itong negative 0.933, this is your Y. Okay, itong 0.282, this is your P. The probability of being accepted or not accepted. Okay, so that's the difference. No? Itong, again, itong Y na to, yung sinolve natin, Y is equal to, di ba? Ito yun. Y is equal to this one, right? Y siya. No? And remember, Y is your log odds ratio. Okay? Now, what R generates here, yung prediction, is your p-value. Okay, so it's different. No? Y is different from your p. But that can easily be solved. So ito, pinakita ko dito. How do we now compute for your p if we know y? Kasi we're not interested in the log odds ratio. We know the log odds ratio based on the model. Ito yun. Rather, we're interested in the probability that that person will be accepted, no, yung P natin. Okay, so, okay, let me just, saan ako susulat? Mag-annotate lang ako, guys. Ha? Okay. So we have here y, di ba? Y is equal to log ln, natural logarithm of p over 1 minus p. Okay, the question is, how do we solve for y? How do we solve for p? Okay, kailangan matanggal yung log nito. And to remove yung log, kailangan yung inverse function yung gagamitin natin. We will have to get the exponent, we will have to exponentiate this. No? So let's do that here. Magiging e to the y, okay, is equal to e to the ln of this. And e and ln are inverse functions. So pag renace mo yung ln sa e, okay, makakancel yung ln na yan. So magiging ano na lang to, p over 1 minus p. So that's what's happening here now, no? Okay, so how do we now solve for this? Ang kailangan natin si p. How do we solve for p? Okay, so tuloy lang natin, no? Ito, let's cross multiply this with e to the y, diba? Times 1 minus p. Right? Sige, tuloy-tuloy ko na. 1 minus p is equal to p. Okay? So itong 1 minus p, guys, transpose ko sa kabila, naging ganito, no? So let's do this. E to the y minus, distribute natin to, e to the y times p is equal to p. Right? And then let's collect the terms. Ito, i-transpose natin sa kabila kasi pareho may p sila. So this becomes e to the y is equal to, so this is negative, becomes positive here. So this becomes p plus e to the y times p, and then factor out p. Factor out natin si p. Tapos e to the y plus 1. Yan. Okay? Therefore, p now is your e to the y over e to the y plus 1. Yan. So this is now the conversion. If we know y, we can solve for p. Okay? So what the model will give us is the y value, log odds ratio. But we don't need the log odds ratio. What we want rather is the probability. Probability ang gusto natin. Okay? Are you copying this, class? So, clear ba yung yung pag-compute ng P? Kung alam natin yung Y. Kasi directly ang mako-compute natin si Y, yung log odds ratio. Kasi yun yung model natin, di ba? So we will have to convert Y into P, and the formula for that is P is equal to e to the Y over e to the Y plus 1. Okay, paki-chat nga please kung clear. Okay, thank you. I hope the others are able to follow. Kung may mga questions, please feel free to ask questions. Okay, somebody copying this, i-click clear ko na to. Do you need a few more seconds to copy? If you're copying, okay, copy na. All right, so click clear ko na yung drawings, guys. Okay, so let's go back here. Ito, no? Okay, so given this, y, solve natin siya. exp, exponential ni Control C, Control V, and divided by, copy this, Control C, Control V, and then put natin sa parentheses, oops, plus 1. Okay. Sige nga guys, ano nga, class, check nga kung what this will give us.
Uh, 0.282, sir. Yeah.
Pareho?
Same. Yes, po, sir.
Yeah. Okay. Thank you. Thank you, James. How about the others, guys? Paki-chat naman if you got 2 point. Yeah. Thank you. Yeah. Thank you, Charles. The others, please. Okay. Thank you, Martina. Okay. Let's give a few more seconds to your classmates. Good. 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 I'm happy. All right. So a few more seconds. Let me run this also. I'm getting 282283. Okay. All right. So now we know where the predicted value comes from. Yung pina, ito mga pina to guys, yung predicted value. Okay, so we have to check how our model fared. Okay ba yung model natin? Kasi 325 yung nasa train dataset natin. Let's see if naging okay yung ano natin, no? Yung model natin. Okay, so compute for y. Okay, ito exercise na lang sa inyo to, no? For individual tree, just to check. You can check the other individuals. No? All right, so let's now see. Okay, we're creating this value pred1. Okay. So if else, ano yung P1 natin? Di ba P1 natin yung mga p-values natin? Diba? Ito, no? 282, 299. So let's create an object called pred1 and let's convert na kapag greater than 0.5 siya, gawing 1, and kapag, of course, kapag less than 0.5, gagawing 0. So instead of the probabilities, okay, instead of yung mga 0.282, 0.299, we're going to create an object called pred1 that converts yung mga probabilities into either 1 or 0. So if P1 is greater than 0.05, 0.5, then convert it to 1. Otherwise, gawin niyang 0. Okay, let's run this first. Control Enter. Okay, so we now have this pred1. Diba? And tingnan nyo, class, nakaano na siya. naka-zero, naka-binary na siya. 0, 0, 1. Yun yung una. Okay, tama ba? 0, 0, 1. Let's see. 0, 0, 1. Tama. No? Okay, let me pause again for a while. Pause. Okay ba? Naintindihan yung ano? Yung nangyari dito, yung if-else function natin. We're basing it on this object P1 which contains all the P values of the trained data set. Okay. For all P1s greater than 0.5, then make it 1. Otherwise, make it 0. And then side by side natin dun sa, okay, tingnan natin yung, okay. Tapos lagay din natin dito yung head ng, ito yung train natin. Okay. So yung dollar ko. Train, admit. No? Then. Okay. So let me run this. Okay. So here we can see, parang yung kanina to, kaso mga zeros or ones ito. No? 0, 1, 1. So may mga tamang prediction, may mga mali prediction. Okay. So let's now create our confusion matrix. Okay. So what's a confusion matrix? A confusion matrix is a table that shows ano yung tamang prediction natin at saka ano yung maling prediction natin. Okay. So let's take a look at the syntax. So we have here tab 1 for table 1, and then we're using this function table. Okay, on the rows, we're going to put yung predicted value natin. So ito yung pangalan ng row, predicted, and then it will be your pred1, and then sa column, yung actual natin, and it will come from yung train natin, yung admit variable. Okay, so let's run this. Okay. So we can see here, this is the confusion matrix. No? So here, ito yung predict natin na will not be admitted. Tapos yung actual na hindi na admit is 208. So this is a correct, no? Correct prediction to 208. Predict natin na 0 siya, na hindi ma-admit. Pero sa reality, na-admit siya. So maling prediction to, 73. We predicted it to be admitted, but actually, itong mga taong to, hindi sila na-admit. So 15. Our model predicted that the person will be admitted, and indeed, it was admitted. So you can see here that the correct prediction is nasa diagonals. 208 at saka 29. Diba? So 0, 0, match, 1, 1, match. Okay, so this is what we call the confusion matrix. Okay, so we can now compute for the ratio, proportion ng tamang prediction. So it's 208 plus 29 over the total of this. Okay, over 325. So we're going to do this. Sum natin yung diagonal ng tab 1. This is tab 1, di ba? So i-add niyo yung diagonals nito divided by yung total ng tab 1. Okay? And on the other hand, the incorrect prediction will be just be 1 minus this one. Okay? So run natin to. Okay. So the correct prediction is 73% and the wrong prediction is 27%. So that's how our model fared. Okay? All right. It's already time, class. So next meeting, tutuloy natin to. No? Gagawin natin yung test data set natin. We will see if how it works with our test data set. Kasi trained data set to. Tingnan natin kung if it still works with our testing data set. Okay? So that's what we're going to continue next time. And I'll see kung kasi may iba pa tayong check na data models. All right. Clear so far, class? Any questions? Did you learn something today, guys? Yung logistic regression natin. Okay, so you know what to do, guys. Hanap na kayo ng data. Maglalagay ako dun sa natin sa spreadsheet natin. Again, no repetition of data. Yung dating sinabi ko na pwede yung gamitin nyo for logistic regression, yun ang pwede yung gawin. You can already start with the model kasi alam nyo na naman di ba? Alam nyo na kung paano how to do your logistic regression. Okay, so with that, guys, let's stop recording.